that are occurring that are, again, we couldn't explain. There's now an emerging field that we're starting to do some analysis on of toxicodynamics. You know, can you begin to make mathematical underpinnings of toxicity of devices based on their size, charge, and other chemical properties? It's again a new field that people are talking about, but can we begin to predict toxicity? This type of assay would allow you to do some of that if you follow it rigorously. You might begin, and you have some endpoints that shift. You might be able to begin to make mathematical models to look at nanodevice toxicity, just like you do with pharmacokinetics, right? In vivo with these devices, though, when you're inside an animal, right, when you got a cell on a petri dish, you can see effects. But what we found was when you went in an animal can fix things, right? The body heals things. The body gets rid of things that are bad. The body detoxifies things. So even though we saw some toxic effects in vitro, the same devices in vivo, I'll just cut to the end point, didn't really show those toxic effects. We think it's because the body can fix things over time, right? Looking 2 weeks and over 3 months, short-term and long-term at weights, positive, negative, neutral, 5 nanometer nano devices, we didn't see toxicity. Looking at a whole host of electrolytes and blood markers, again, to look at hematologic toxicity and then to look at things like liver function or kidney function to get clues to damage to those areas. We, again, if you look at 2 weeks and you look at 3 months, for every device tested positive, negative, neutral versus PBS, we saw no toxicity during the serum analyses, no matter what we looked at. And then histopathologically, with a very experienced histopathologist, you can take the organs, put them on a slide, right, and then try to look for toxicity, again, with the devices. And again, with multiple analyses, looking at many, many different organs.